Alright guys and girls and people of the world, what we are doing today is we are testing different gases. Here what we have is the equipment. So we've got marble chips with a spatula that you can see just there, hydrochloric acid with a pipette, we have a small test tube, a larger boiling tube with a delivery tube connected, and calcium hydroxide solution, aka lime water, and a pipette. Now as you can see, I've kept the two solutions away from each other and the pipette separate so we can avoid contamination. As for the process, it's really simple. What you're going to do first is take some of your lime water using your pipette and quite simply take about maybe 3 or 4 pipettes worth and just place it into the test tube. Right, so 2 is enough. In fact, 2 is more than enough. You don't need that much. Then what you're going to do is you're going to take the calcium carbonate, which is the marble chip, and add it into the boiling tube. And then add the hydrochloric acid in. So I'm going to take some calcium carbonate with a spatula. It's quite difficult to record and do this at the same time, so what I'm going to do, I'm going to stop recording and just place it in. So there you have it. I have placed my calcium carbonate into the boiling tube, and what you want to aim for though, and what you want to make sure, and this is just to make sure that you're working efficiently, right, is once you're done with something, you put the lids back on where appropriate, right. Now what we're going to do is we're going to add the hydrochloric acid into the boiling tube, and as soon as you place that in, now you want maybe 3 to 4 pipettes worth of that, and then straight away you put your bung back on and you stick the delivery tube into, so you stick the bung here and the delivery tube goes into here, and we're collecting carbon dioxide and we need to see what happens. And that's what I've done here. So if you noticed, the delivery tube is right in the solution of lime water. Now, of course, if you want to make this happen quicker, what you can do is you can shake, aka stir, the boiling tube so that the chemical reaction happens faster, so the frequency of collisions increase. Now, as you can notice, what's happening is it's turning cloudy, but initially it wasn't. Initially it was clear. So what that means is that the first part that was coming out of the boiling tube was not carbon dioxide. It was the air that was already in the boiling tube. But as you can see, it's now become cloudy. And that is the test for carbon dioxide. It is quite simply bubble carbon dioxide into lime water. The lime water will turn cloudy. Okay, with our second station, what we're going to be doing is testing for oxygen. Now, what we're going to be using is hydrogen peroxide over there, and manganese oxide over here in the pot. And basically, hydrogen peroxide breaks down naturally into water and oxygen. However, it takes a very long time to do that by itself. So what we're going to use is a catalyst called manganese oxide. It's a black powder. It's in the pot. And basically what a catalyst does is it speeds up the rate of reaction. So it's going to speed up the breakdown of hydrogen peroxide into water and oxygen. But the amazing thing about a catalyst is it doesn't get used up. So in other words, you only need a tiny bit of the catalyst because it's not going to be used up. And the hydrogen peroxide you can add in as well. So literally all you need is a small amount of manganese oxide, which you're going to pick up using the spatula, and then we'll see what we do from there. So there is the small amount of manganese oxide, the black powder, which is going to be our catalyst. Literally you do not need a lot, just a tiny bit, because remember it's not going to be used up. Next I'm going to set my Bunsen burner alight, because we're going to need that. So my Bunsen burner is alight. It's on safety flame so that everyone can see it. And what we need to do is we need to make a glowing splint. Now a lot of people, interestingly enough, do not know what a glowing splint is because they read it, but then they don't know what it is. So basically a glowing splint is you set it alight and then you blow it out. And I blew up my Bunsen burner as well, which is exactly what you don't want to do. So let me set that alight again. So let's try that again. So you set it alight and you blow not in the direction of the Bunsen burner. So, and that is a glowing splint now. So it's just glowing literally. And then what you're going to do is once you've placed the hydrogen peroxide into your catalyst, then as soon as that's happened, you get a glowing splint and you place it in and you see what happens. Now, let me just place, what I'm going to do, I'm going to take my pipette and pipette in some hydrogen peroxide into that test tube. So literally, that was just from one pipette worth of whatever in the hydrogen peroxide. So I'm just going to turn that off and I'm going to place it in and let's see what happens. Can you see that? Did you see that? It lit it again. So this is a glowing splint, right? It's not lit. Fully place it in. And it will relight it. And there it is, it's relit. And that is the test for oxygen. It's quite cool. But obviously it's a bit tricky doing this and holding a phone. So that is testing for oxygen. Okay, this is our third practical, and in this one what we're going to be testing is hydrogen gas. Right, and what we're going to be using is hydrochloric acid, some magnesium strips, and a conical flask with a pipette and of course some splints. Now with this procedure there is a proper way of doing it where basically you feed it into you have a delivery tube here and then it goes into a trough of water and then you fill up. But for this purposes all we're doing is testing for hydrogen gas, so we're not going to do it the difficult way. We're going to do it nice and simple. So what you do is you add the magnesium ribbon. Let me show you how that looks, or magnesium strips. You add those into the conical flask. The more, the better. And you add the hydrochloric acid in as well. The more, the better. I mean, obviously you don't want like a massive amount that's going to fill it up, but a decent amount. And then all you're going to simply do is place the test tube inside it, and that's going to collect the hydrogen gas that's produced. Once you've collected the hydrogen gas that's produced, do not turn it right way up like that, because the hydrogen will escape. So you want to collect the hydrogen gas, maybe hold it for about 30 seconds to a minute. The longer the better. Take it out, light your splint, and place the splint inside the test tube, and it should make a squeaky pop. Let me show you now. So I've just placed the magnesium strips in. I'm going to put the lid back on. Like I said, let's keep it good practice. And now what I'm going to do, I'm going to get a pipette and place maybe about 3 to 4 pipettes worth of hydrochloric acid into the magnesium ribbon or strips, whatever. Okay, so I've put in about 4 pipettes worth, and now I'm just going to place this inside here and collect the hydrogen gas. And I'm going to leave it in for about a minute, and then we'll come back and do the squeaky pop test. To make the reaction happen quicker, of course, you can hold both in your hand and just give it a good stir. And that'll make the reaction happen quicker because, of course, the frequency of collisions is occurring quicker. The frequency of collision between the hydrochloric acid and the magnesium. Now make sure you don't put the test tube in the solution. Okay, you want it above the solution, just collecting that hydrogen gas. Okay, so I think hopefully that's enough. Like sometimes people try it and it's not enough. No big deal, just try again. So I'm going to pause it right now. So now what you're going to do is you're going to take your test tube, remember it's still upside down. You're going to light a splint, so you're going to make sure it's lit properly, and then you're going to place it inside. And that was it. So that's your squeaky pop test. And so those are the 3 gases, carbon dioxide, oxygen, and hydrogen.